Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we solve question 9 of 2023 ISC Computer Science theory paper. And before we begin, it is a request to please subscribe to my channel, because out of 100 views, only 1 or 2 are subscribed, and a subscription is very important. So please subscribe to my channel. So let's begin. So this is question 9 of ISC 2023 Computer Science theory paper. Give this a reading. Alright, so the first thing, as I always tell you, the most important part is to making sure that you read the question carefully from the first letter to the last letter. Okay, so in this case we have to create a class deq. Okay, we don't call it deQueue, we call it deq. The actual pronunciation is deq, and it is a linear data structure which enables the user to add and remove integers from the either end, from front or rear. Okay, so these are the data members given, these are the functions given, and you have to specify the class deq, given details of the functions, addFront, int, popFront. Assume that the other functions have been defined. Okay, the main function algorithm not be written, and finally differentiating between a stack and a queue. Okay, now you are just supposed to write addFront and popFront. Okay, and the implementations of these two functions depend on how you understand this question. Okay, so suppose if you have this array something like this 0 0 0 0 0. Okay, so this has 5 locations. Okay, and in the requirements it is given that front equal to 0 and rear equal to 0. Okay, so if front starts at 0, rear starts at 0 2. Okay, at the 0th index, the first location. So if you add to rear, rear moves forward. Okay, so if you add to front, the front should move backwards. Okay, that is the only way you can replicate the adding of integers from both front and rear. Okay, according to the requirements of this question. Okay, so what I'm trying to say, suppose if we have something like this, I have my rear and front at 0. Okay, rear and front at 0, and suppose my capacity is, I'll make it 10. Okay, now when I'm add 10 to rear. Okay, when you add 10 to rear, what happens is you add 10 at this index because rear is here, rear moves here, front remains the same. Then you say I want to add 20 to rear. You add 20 to rear, rear is at this index, you add 20 here, rear moves forward. Okay, again you say you add 30 to rear. Okay, rear is at this index, you make this 30, rear moves forward at this index. Okay, pointing to this location. Now if you are trying to add to front, say add 40 to front. Okay, so this is your configuration right now, and you want to add 40 here, but front is pointing to 0, which already has a value 10, and it is a part of the queue structure, and it is the value at the front. Okay, now in order to add 40 to front, you can take two approaches. One of those can be shifting this entire thing one place, right? Okay, and making a place here. What I'm trying to say is, when you shift, okay, you lose out one place here. Okay, rear moves forward and you make this 40. Okay, and front stays here because you have added to the front, and this is the frontmost element. This is one approach you can take. So this is basically making a space at front and adding to the front. Okay, this is one approach. Then we copy this again. Okay, and we have to add 40 to front in this very same configuration. Okay, and this is my second approach. Now in this approach, I say I cannot add to front if front cannot move left. Okay, there is no index to the left of front, so I cannot add to front. As simple as that. So in this case, we get overflow because you cannot add to front. Alright, and why do I have to explain you these two cases? Because they are creating an array. Okay, and they are starting at front and rear both to 0. Okay, if you look at the requirements, okay, create an array to hold integer elements, front is 0, rear is 0. Okay, and the basic difference between these two is, in this second case, okay, you do have these extra spaces, your rear is still here. Okay, but you cannot add to front because front cannot move left. But in this case, when you are making a space at front, you are actually using a space, okay, and setting 40 to front. All right, and I don't want to complicate this a lot, and I'm telling you this because I'm just trying to stick to the requirements of this question. Okay, so given these requirements, I will have to code. So basically, if we have something like this, okay, then I say I have to remove from front. Okay, when I have to remove from front, my 10 is at the front. Okay, this was the last configuration after we added 10, 20, 30. Okay, I can remove from front because there is 10 at front. Okay, so front goes here, this remains 10 because you cannot actually delete a location, and rear stays here. Okay, so now when you add to front, you say add, say maybe 40 to front. Okay, you add 40 here and front goes left, rear stays the same. Okay, that is what I meant when I said front needs a space to left if it wants to add to the front. Okay, if we are considering this second case, and I don't recommend taking this first approach because these are just 4 marks, man. For 4 marks they won't ask you to think at such a complicated level. So the basic concept is if front can move left, you can add to front. If rear can move right, you can add to rear. All right. Okay, and keeping that in mind, I'm going to code these two functions. Okay, so let me write the remainder part of the class. So this is the class deck. It has 4 data members as mentioned here. Okay, then we have this constructor that takes an integer I, which is the capacity. Okay, which is the limit basically. We have to complete addFront and we have to complete popFront, right? addFront and popFront. Okay, and I have kept the other methods hidden. Once I complete this and run this, I'll show you. Okay, so we are taking the second approach here, which says that I cannot add to front if front cannot move left. Okay, and when is it that front cannot move left? If front is at 0, it cannot move left. So for overflow, okay, you cannot add to front, right? You say overflow from front. So you say system.out.println overflow from front. Okay, that's it, right? And you return. Okay, else if we can add to front, which will be in the case if front can move one space left. So in that case, we add the new value to the location left of front and move front there. Okay, add the new value to location left of front. Okay, and move front there. So how do you complete now popFront? So basically you keep removing from front. Okay, so you say remove from front. Okay, front moves here. Okay, then you say this again. Again, we are actually not changing the values, we are just moving the front. Okay, remove front again, front moves here. Okay, and when you say remove front again, front comes here. Okay, so when front and rear are at the same index, that is the point. We cannot remove anything from the queue, you cannot remove anything from the front, which is the case when we have a starting queue. Alright, so when front equal to rear, if front equal to rear, okay, return minus 999, because if there is nothing to return, okay, return minus 999. Okay, alright, and this condition will hold for pop rear as well, because this is a double-ended queue. If you cannot remove an element from front, it means there is no element to remove, which means you cannot remove an element from rear as well. Okay, it means the queue is empty. Okay, this deck is empty. All right, so this is the case if the deck is empty. So if there is nothing to remove from front, okay, else if there is something to remove from front, what are we doing? So if you look at this case, okay, we are removing from front. So this is the value we are removing and moving front forward by 1. Okay, so the value to be removed is at front. So I say QRR at front. Okay, move front forward and return the remove value. Alright, and this is your popFront and this is your addFront for these two methods. Okay, so let me create an object and check this out. So I'm creating a deck object. The capacity, the limit is 10. I'm going to show you the empty deck first, then add rear show, add rear show, add rear show. Okay, so let me just run this. I'll say Java C, let's say Java ISC, it compiles. So everything seems to be good. Okay, so when you have this deck which is empty, when you show, you have nothing. Okay, within the brackets. So this means this is the front side, this means this is the rear side. When you add rear, you get 5 as the only element. So this element is at rear as well as this element is at front because it's the only element. Okay. When you add 6 again, 6 adds to the rear side, so it becomes like this. When you add 7 again to the rear side, it becomes something like this. So you added 5, 6, 7 on the rear side, which is okay. Alright. Now I will remove from front. Okay. So I'll say system.out.println removed from front, which is okay deq.popFront. Okay, I will remove an item from the front and then show. So I should be able to remove 5 which is at the front. I should just get 6, 7. Alright, compile, run. So remove from front is 5 and I get 6, 7 only. If I repeat this, okay, I get 6 as the next element removed from front and 7 is the only element left. So compile, run, and you can see. Oh, I did not save, sorry. Compile again, run again. Okay, so you can see the next element removed from front is 6 and the 7 is the only element left. Okay, now I add to front. Okay, so I say deq dot add front. I say maybe 29. Okay, and show. Okay, and show. So when I add to front, it should be 29, 7. So compile, run, it is 29, 7, adding 29 to the front. When I add one more element to front again, I say maybe 39. Okay, compile, run. So 39, 29 and 7. Okay, now if I try to add to front again, okay, I say maybe 71. Okay, show. I will compile, run. Now I get overflow from front because I cannot add to front as long as front is at 0. Okay, so what happened was when you added to rear move at index 0, 1, 2. Okay, move at the third index. When you remove from front moved 2 indices forward, so it moved at 2. When you added to front again, it went back to 0. And when you're trying to add again, it won't add because front is at 0. So if I print the front right now, if I say println front, okay, and I say dot front, okay, and I make this front public. Oh, it is public, it is supposed to be private, okay, but I'll make it public just to check what the value front is. Okay, so when front comes at 0, right, I'll copy it here. When front comes at 0, you get overflow. So I'll compile, run. Okay, front is at 0, and the same thing will happen, okay, when you try to add to an empty queue. Okay, right now front is at 0 again, so it won't work. Okay, so if you see, the first output is front is at 0, right, and this is because the way the question has been framed, right. Ideally when you're coding a deck, this is not supposed to happen. You should be able to move front as long as there is capacity. Okay, because if you see, we have a capacity of 10, but I cannot add from front because front is at 0, and this is because of the requirements of the question. Okay, all right. So keeping in mind the requirements again, as I told you, we always stick to the requirements. This is the code to the question. Okay, let me show you the remaining code. This is the constructor. Okay, we make this private again. Okay, we remove this, and we remove this. Okay, so let me compile and check. Yep, no errors. Okay, and this is the show. You start from front and you go to less than the rear. Okay, and as I told you, empty condition will be the same. Okay, because if there is one single element, it is the element at the front and it is the element at the rear. So pop rear empty condition is the same, is at front basically. Okay, so these two empty conditions are the same. But when you're removing from front, you get the value at rear -1 and you do rear minus. Okay, and then you add to rear. Okay, all right, so we can remove some values from rear. So I'll comment this out. Okay, I'll say dequeue. Let's see what is the, I'll clear and compile. Oh, clear, compile, check. Okay, So I don't need this either. Okay, clear, compile and check again. It's okay. Let me run this. Okay, so I have something like this. So I can remove 3 values from rare. Okay, so I'll say removed from rare, remove from rare, pop rare. Okay, show, and do this twice more. Okay, compile, run. Okay, so the last 3 outputs are removed 7 from rare, remove 29 from rare, remove 39 from rare, and this. And now if I try to remove again, I get minus 999. Okay, clear, compile, run. I get minus 999. Okay, and now that if you try to remove from front either, you get the same value, same output, minus 999, because the deck is empty. Okay, clear, compile. Okay, same. All right, so this was the solution to this problem. Only 2 methods were there, but the approach to this problem has to be very clear, and I always tell you that you have to find the correct solution, the best solution to the given requirements. Okay, so I will add the link to the code to this solution as well, and if you want me to solve this question separately on a whiteboard and explain it in detail, I can do that as well. Okay, you just have to let me know in the comments. And also if you want me to solve this in Hindi, I can do that as well on my Hindi channel. Okay, you just have to let me know in the comments. All right, okay, so I hope you like this video, this was helpful. So please subscribe to my channel, and if there was something that you did not like about this video, please just don't press the dislike button. Please also let me know in the comments what was it that you did not like about this video, so that I can improve on my further videos. And you can always let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. Thank you.